Hey, John here. In Python, there's two ways to create singletons. There's a crazy complicated way that's similar to how you do it in Java, C Sharp, or C++, and then there's a very easy way to do it. Let's look at both. Okay, first a bit of background. What is a singleton? We know what a class is, and if you invoke that class and store it in a variable, you've got one copy or an instance or an object of that class. And we'll just call them objects because that's the Pythonic way of referring to them. And you can have many objects of the same class, but sometimes that's not what you want. Sometimes you want to be only one class in the entire project. All your source code share that one class, and you don't want there to be two copies out there. This is especially important when you're working with external systems or databases or other kind of stuff where you really need to tamp down and control exactly how that class is used. And so how do you make a singleton in Python? Let's look at the complicated way because I said I would. Here I'm starting with a real world-ish kind of project. I just wanted to use some actual code so we can take a look at something that seems realistic. This is a quick and dirty to-do app, a to-do API that allows you to create and save and list out to-dos. And here at the bottom, we've got a main.py, which pulls in these routes from routes.py, and routes.py has three endpoints, which each access a database class. And here in the database class, we got to define database.py. We're creating an instance. Here's the definition of the database class itself. We've got one instance variable in here where the database was stored. In this case, I'm using SQLite 3 to store it locally because, again, I want to keep this nice and simple. And a class method that essentially it's a meta method that acts on the class itself rather than on the contents of the class. In this case, it's accessing a global variable stored right here inside of the database.py file. And if the variable hasn't been set yet, which it wouldn't on first boot up here, it creates a copy or it creates a new instance of database, stores it in the instance variable, and returns that variable. So whoever calls this first, in this case I have an example call being made here, database.instance. It's throwing it away, but that's okay. It's ensuring that it's created on the very beginning. This is probably overkill because whoever calls this first will create the instance. And then here in the routes, everything's using this. Here at the top, I'm importing the database class again. And from there, I'm getting the instance and then here creating the to-do item and here getting the to-do items and here database.getInstance deleting the to-do items. And this works. It works just fine. And the idea here is that because while you certainly could access the instance variable directly, there's no way to stop anyone from doing that. Yeah, it works because you're always using getInstance. So whoever calls it first creates it and they only get that singleton. But there's a much easier way to do this. And it's actually enforced by Python itself. Let me show you real fast. I'm going to delete that instance variable. I'm going to delete the class definition. I'm going to delete this getInstance thing altogether. I'm going to turn all of this into just a plain Python file because, and this is not really explained in a lot of the documentation out there, in Python, everything is an object. An integer is an object, a string is an object, even though in other languages those might be basic data types, but in Python, everything is an object, including imports. With this statement up here where it imports SQLite 3, it's creating a singleton object called SQLite 3. And it can store variables in it and you can do all kinds of stuff with it. Every file in this project, except for perhaps main.py, these are all classes. Even though you're not going to see any class definitions around it, they're all classes because anything put into the main namespace of this file is a class variable, or more accurately, an instance variable for the class. So database.py is a class. So here in routes.py, you can think of that as like database equals and you can't really do this, but think of it as like database.py, an instance of it. I mean, you can't do that. As you can see, my editor is yelling at me saying, you can't do that. And you can't. But I can just do an import database or a reference to the singleton stored in this database variable. And then down here, all I have to do is say database.create to do. That's it. Done. Now, whoever does the first import here, which is up here, will create the instance. And then any other imports found in my source code will go and call that same file module object is what it's called. And that is a singleton shared among the whole thing. In fact, let me show you kind of a interesting thing I can do in the Python console here. I'm going to import database. Database is now, like I said, it's already a singleton just by doing that. Database is actually the name of the identifier for that instance. So if I type database path, I got a copy of it. If I were to change it, my entire program now sees that the database instance has been changed as the database path changed. In fact, I can do this to it, which is kind of mind-blowing. I just created a brand new variable, even though there is no foobar variable in this entire class. It's as if I just typed it in down here. Foobar is now in that instance. Now, as soon as I delete that instance, you'll never see it again, but it's in there. So if I go and reference it, it's 4. I just stored a whole new variable in there. Are there reasons to go ahead and declare a class? Actually, there are 3 good ones. The first one, of course, is the obvious one. What if you want multiple instances of it? So, for example, in here, I think it's models.py. I have a to-do class defined, and it's a data class. Well, I want there to be multiple to-dos. So, but there's also a reason maybe this database is using a library that it needs to inherit some characteristics from. Then you're forced to go back to the enforcing a singleton thing, which can be a pain. Although you don't have to do what I did with that getter. You can actually just create a variable at the bottom. Let's go ahead and do a crazy thing with this to do. Let's say one to do. That one to do is a singleton because it's only been created once. And it's actually now part of the models.py singleton class. So this is the only copy there is. And so I didn't really have to do that getter that I showed you easily. You can just do this and that'll work too. But yeah, if you're inheriting from something, you really have no choice because you can't put inheritance on the entire .py file. There's no way to do that. So then you have to put an explicit class. And the third reason you might want to create a class for a source code file is if you're doing some kind of factory class. Like let's say you want there to be multiple databases talking to different database files. Maybe you say there's 3 of them and they all have their own names. So you create a dictionary and it points to 3 different instances of a class. Well, in that case, you're gonna have to do the old traditional class definition. And then very carefully only make sure 3 instances are created. So essentially you've got 3 singletons assigned in that dictionary. But this stuff is fun to talk about. I do have a book I recommend if you want to really get into the insides and outsides of Python called Fluent Python. It's kind of thick, so don't do that. Don't read this on day 1. But it shows you how, in great depth, how generators work and how magic methods work and all of the other weirdness of Python. And then it also goes through why it's very object oriented. I should reword that. It's not object oriented in the class sense. It's oriented towards object instances. Is that a better way to put it? I suppose. At any rate, hopefully this was fun to listen to. I appreciate you watching. Thank you.